Welcome back to the Agentic Insider. I'm your host, Philip Swan. In this show, we explore cutting-edge ideas and trends in AI and data, as well as hear from other industry thought leaders in the AI space. This podcast is brought to you by Iridius AI, committed to safe and responsible AI innovation. Let's dig in. Welcome back to this week's edition of the Agentic Insider. We're doing another internal focused episode with the great Peter Larsen and the amazing Spencer Bentley. Peter is our Chief Technical Officer and Spencer is our AI Technical Fellow. And I'm here with Alistair, and we're going to be digging in today regarding the 4 provisional patents that we have recently filed and the significance of them and the importance to the industry of why we're doing that. So, Alistair, why did we even pursue patents to begin with?
Well, I think one of the most important things here is, from a company perspective, competitive positioning matters. And so, we didn't know originally when we started how many patents we would need. Was it one? Was it more? And the thing with the provisional patent is it allows you to get patent pending. It allows you to be able to have 12 months to file the full patents while also sticking a stake in the ground that says, this is the filing date that we can backdate it to. I think that the reason we wanted to file these was because, from a corporate perspective, we want to protect the work that we're doing. We want to make sure that we're able to sort of get in front of the problem that we're seeing out there, and that problem's quite broad. Okay, in terms of there's a lot of work happening right now around people building agents, very large, agents that seem to do everything, and using a GPT or a foundation model, something like that, to be able to create something that has a very large surface area, which makes them, significantly more likely to fail because they're capable of doing so much. And the approach here was that we said, why don't we do something different? Why don't we build out a multi-agent system fabric? Why don't we build, a set of entitlements that go with that? Why don't we embed the compliance pieces that we need in here, and ultimately then build a solution factory that can build off of the top of this? And I think for us here, as we worked through this, the 4 of us and Jandy and Emily as well, I think that we ended up with 4 patents that are pretty robust. They put together some key things where we had some breakthroughs, especially around the idea of this intelligent solution factory that we haven't seen before. That was sort of the 4th patent that we wanted to get to. And for us, I think, we're talking about 75,000 odd words, 48 drawings, some almost 300 pages of technical content here on how this all lays out. And I think this gives us an opportunity at Iridius to be able to really talk about the value that we can bring, but know that it's grounded in good technical principles.
But so in the ultimate long run, Alistair, I mean, this is great why we pursued it. What is the real significance? I mean, are we talking about, as you know, I've been involved with several startups. There's only been one that we've gone to this level of IP protection. Many, if not most, startups don't even bother going down IP protection beyond copyright. So why this level of rigor at this stage of our developments? And
yeah, I agree with you. I mean, I haven't seen a startup with this level of IP protected rigor, in my experience either. And I think partly that's because we had a series of breakthroughs that we wanted to be able to protect, and I think long term it also helps with the valuation of a company, because if you're able to protect the IP and stick a stake in the ground that says, hey, this is ours and this is why we're doing it this way, I think it gives investors and it gives customers the confidence that what's being done here is something that they can rely on and depend on. And I think that makes our value proposition a little bit more valuable, a little bit more comprehensive too.
I agree. I mean, look, my example is that one company I was referencing, that we not only filed our own patents, but we actually acquired a large portfolio of patents. Some people may remember Hayes modems if we're old enough to remember back in those days. We bought all of the Hayes modem patents. We were in the telecommunications space, and being able to protect our customers and indemnify our customers in a highly litigious environments, which at the time was the beginnings of voice over IP, was absolutely crucial to our success. And we were able to drive a valuation that and multiple on the company based on having those patents. To me, this is part of what we're doing here. Do you think?
So we should get into them. Let's talk about what we are.
Absolutely. So the star is like Peter and Spencer of, if you could go through, and Peter, let's talk through some of the patents, and what it enables, and giving our audience what the purpose and the real world application example of each patent may be. Is that something you can do, Peter?
Absolutely. So I think as we were wrapping our minds around what an enterprise customer would want from an agentic solution, we think that they want to have enterprise agents be safe and compliant and scalable, and a bunch of other enterprise abilities by default. So you don't want to have to craft that into every agent that you create, right? We know we are going into an agentic future, but we want to delegate that aspect of the agents to somebody else. That's why we created this multi-agent infrastructure that is able to communicate between agents and have many versions of agents to scale all the way down from a single person use to internet scale if need be. And while maintaining that safety and security that has prevented many projects with AI to get off the ground. So we basically say, hey, here are the table stakes for talking about agentic AI. It has to be safe. I have to be able to trust and not worry about my agent doing something nasty to me.
And so patent number one is really about this scalable multi-agent system, or MAS fabric. So let's talk a little bit about that. So tell us a little bit about the principles behind this and what the patent's about.
Yeah. So because we wanted to end up in a place where we can delegate things to this MAS infrastructure, we needed to create a simple building block. So think of Lego as an example, right? A simple building block in our environment is a piece of code or something that is imbued with a code life, maybe from an AI, maybe not. It has a life of receiving messages and sending messages. That is all it knows. And there's a little bit of plumbing in terms of logging what it's doing, and so somebody can monitor it. But fundamentally, from a functional point of view, it just processes messages. So everything, it can become an agent in that system as long as you can put a wrapper around it that receives messages and generates messages.
So how do you scale in that environment, Peter?
Yeah, so the trick there is to reduce the agent behavior and hide it behind a scaling mechanism. So you can craft this in many ways, but one of the ways of doing that is Kubernetes, right? You put the agents together, you package them in containers, and this is something we call semantic overloading, where we have many agents in the same container, and then whenever an agent sends a message, it may in fact cause another copy of the recipient to be spun up in case the existing copies are already busy making a request for other customers, so to speak. So the environment scales transparently to any individual agent and their function, and it scales to the limits of what an Azure, GCP, or AWS can offer.
Which is amazing. But now you start getting into, okay, you were talking about individual containers now. Can agents talk to other agents in other containers?
Yes. So agents do not know where other agents live. So there is essentially a routing mechanism that allows agents to be transparently talk to other agents that they have been told are good at solving a particular problem, and they don't need to know where they are.
So ideally, those containers could even be running on other machines, correct?
That's exactly right. And we're talking to people who care about devices, right? So all of a sudden, you can imagine, as long as you can get the security down, that something is running on my Kindle and something is running on my cloud.
Well, let's double click into that, because security is something that's near and dear to all of our hearts, right? And how we're handling that. I mean, we're doing the basic we're not only just doing the basic protections, we actually have some pretty comprehensive security features built into the product to do that. Not just how we handle data and everything else. Do we want to think about how what do we protect, and think about this, and part of what we're talking about is the zero trust model in this architecture.
That's exactly right, and there are many elements from existing notions of web services and SOA and stuff like that carry over, right? If you go into a cloud like that, let's say Azure, right? You have infrastructure in Azure to identify things that are doing stuff on behalf of humans, right? So in my Azure, an agent will have an intra ID. So we know who it is. It is cryptographically ensured that this agent is who it says it is. And once you have that level of trust established, you can attach things onto it, right? You can attach entitlements onto that identity. And then you can build on top of that a system where we don't trust each other, but there's certain things that are stay invariant.
And I love that, because we're almost now moving into pattern number 2, which is around agentic entitlements. And so we've got this model that's built on top of Kubernetes. It extends Kubernetes, but it allows it to be able to scale up and down with semantic scaling. And I think in addition, Philip, to touch on to the point that you're making here, one of the architectural pieces that we have in this is the concept of a postman. Okay. To Peter's point earlier, the agents don't know where all the other agents are, but the postman is able to deliver messages. So messages go transiting through the postman, which is again an infinitely scalable resource, and it transits the messages, outside of the pod to other pods. And I think at that point, then, before a postman delivers a message, it validates that the entitlements that is coming with the message are those that the agent that it is delivering to are correct. So it's the same with any letter. You're looking at it. Is this the right name on the address? Is it the right the right address? Is it formatted correctly? And then specifically, is this address allowed to receive parcels or packages, or is it not allowed to receive things with a battery inside them? I'm extending the analogy here, but ultimately, it's making a decision. So it says, okay, what I'm delivering to, what are you willing to accept? What's in the message? What have I got? Do they match? If so, then we can move ahead and go with the delivery. Peter, do you want to expand from there?
Yeah, I mean, I think that the postman scenario can go very far, right? You can think of ancient Sumerians putting clay envelopes around clay messages with a little script on them, right? And the notion of being able to seal packages with packages inside of them goes very far, right? One of the things that we can do in the environment is to have a transparent adding of stops on a route of messages to other value-adding functionality, so that you can have both oversight from a standards perspective, but any cross-cutting concern can be inserted after the fact. The system can be essentially insert the oversight or the value add across all the existing agents, totally transparent to the functionality of the individual agent.
Absolutely. And let me just go on from there as well. So we're talking about, standing up and establishing a MAS fabric that runs all of these applications and these agentic systems. But it's not only going to be the ones that we instantiate, there are going to be other MAS systems out there. Okay, so then there's the concept of the boundary postman and MCP and A to A. Can you talk a little bit about that?
Yeah, so in many ways, and I want to pull in Spencer here as well to talk about MCP perhaps, because essentially a bunch of companies, Spencer, right, have come up with individual answers to agentic behavior. So maybe you could expand on that.
With MCP specifically, it's worth the elephant in the room is a security concern around MCP. It's not specifically with the security of making the connection to MCP. You can do that. But once you have made the connection, you've then got access to the model directly. And if you can insert improper commands, you can potentially access anything that model has access to. So, for example, if a model has a RAG database, that's a retrieval augmented database, where the model is able to pull from company specific information, and that could be a customer database, it could be anything. If it's connected to the model, you have to make the assumption that this is now public domain, and that was not known before, and so a few companies have come unstuck with that. So one of the things we try and do is build on top of MCP to wrap it in a protective layer. So that's one of the approaches we do is we create an idea of a bubble, and things outside of the bubble will require zero trust and a lot of scrutiny, and that those things within the bubble we can treat less so.
So it's more of a sort of a force field around things that allows us to be able to protect, things going in and out. And as Peter's point earlier, as we can insert almost an infinite number of checks, and balances through this as we route messages, it allows us to ensure that the zero trust principles that Philip was espousing earlier can be used, even if we're talking, from AMAS to any other person's MAS.
One thing, Spencer, you've mentioned in the past, and I love the analogy, is think of MCP as HTTP, and think of of Iridius built around your Iridius core built around that, giving you the S in front of HTTP to give you the security. Is that a fair analogy?
Yeah, it is not exact, because I don't think MCP with OAuth, for those who want to know the more technical definition for it, it is secure. It's great. Mm-hmm. That isn't the problem, which is what HTTPS basically solved. But yes, right. The idea is HTTP was around to start with, and then people realized it wasn't secure enough, so HTTPS was created. MCP at the minute, in its current incarnation, is not secure enough to be allowed out alone. It needs to have a chaperone.
And that's the second patent. The second patent is the chaperone, right? Because HTTPS ensures that you can have a confidential conversation, but it does not ensure that you have a right to talk about it.
Exactly. So why don't we move on a little bit and talk about patent number 3, which is around the idea of the doc rocking and the semantic compliance compiler and things like that. Why don't we talk a little bit about that?
Yeah, so I think it's worthwhile not concentrating on a particular standard or even standards. This is more general. How do you get a large corpus of information and understand it in a reasonable size? Now, you could take the naive approach and take the thing you're interested in and include it in its entirety to the model. And that works. If the document is very large, the context may start to reduce the quality of the output from the model. And if the corpus, so you've got 1,000 documents, each one with 1,000 pages, there's no model in the world that can take that. So what do you do at that point? How do you understand the requirements of something like a ISO standard can have a 70-page document with references to 50 other standards, each referring to other standards, and so you get this great bifurcation of documentation. How do you do that? So one of the realizations we came to was information in general consists of human beings put them in sentences, into paragraphs, into pages. And we do that with almost an unconscious logic. We group topics into sentences. We group groups of topics into paragraphs. We group groups of ideas into pages. And we take advantage of the fact that that is embedded into the information we have in our world. We logically split the information up into its components, along with the rules and the references. So is there a reference to an external document? If there is, we make a note of that. Is there a diagram? Does it contain a formula? Has it got a table? We extract those details and store them formally. And then once we've done that, we've then got a a detailed list of all of the information and how it relates to other parts of the document. And then we can put all of that information into a graph database, and we can build the relationships between the information. When you do that, you can arbitrarily add more documentation to that database, and then you'll occupy the same links. So you can follow from an idea or a concept through the graph. And if we then do something called vectorization, which is where you take an embedding layer from a model, it's a part of this retrieval augmented generation feature that everybody uses. But that vectorization allows us then to very quickly find a location in the graph and then traverse the graph to understand the knowledge around that topic. And that lets us take very esoteric, very complex conceptual ideas and find the context for those and bring them into the AI in a compact form that is directly related to the question being asked, rather than a general, here's the entire document, you work out which bit's important. We're looking through the index, finding the thing that's important, looking at the index, then going, oh, that bit's mentioned in this document, this document, and this document, pulling those pages together and then showing that to the AI, rather than all of the documents. And that's ended up being extremely powerful and forms the basis for the doc grokking system.
Sure. I mean, I think here the big thing is that there are hundreds of regulations out there around AI. I mean, there's hundreds of regulations and thousands of regulations about other things, but for AI specifically, the EU AI Act is 500 pages. Okay. Colorado and Utah have their own pieces of this as well around an AI Act. Texas just put one in for the states. There's California has some. Every single state is doing something. Singapore has regulations around this. So does Australia. So does the UK. So and everyone is looking at what other legislators have done. So governments are looking at what's been done in the past, and in some cases they're referring to the same definitions, but in many cases they're not. And so you end up with, when somebody said, when country A or region A says transparency, it's not exactly the same way that country B or region B is talking about transparency. And if you're a company and you're an enterprise and you have to be compliant with all of these standards around the world in the countries in which you do business, then it suddenly becomes more and more problematic. And then, in addition to that, just as you're saying, Spencer, there are, hundreds of standards around AI, hundreds of best practices more on top of this. And the complexity is almost impossible for people to be able to get. And I think if we're able to bring it all together and then harmonize it and understand where the edge is and where the issues are, and then find a way to be able to help people navigate through that, suddenly we've got a corpus of knowledge, to your point, that can be used to ensure or assure compliance in a lot more a better way, because it's directly related to the pieces that are guiding it.
And just adding as a comment here, right, that yes, the standards body is large. Your corporation's knowledge base is also large, right? So you are going to want to restrict agents to proper behavior, not only to the external standards that you are mandated to do, but also to your own ethics.
Absolutely, and you may have a code of conduct or a way of working. For example, you want the agent to be able to communicate with people, but your organization uses Slack or your organization uses Teams, and also the way that Disney has its employees talk to each other would be different than how Ford has its people talk to each other, and different than Coca-Cola, because they're different companies. They have different codes of conduct, different international, and enterprise standards. And it may well be that the marketing team in France, okay, needs things done slightly differently than the marketing team in Germany. And so now we have corporate standards, European standards, marketing in France standards, and it has to be able to take all of those and overlay them, okay, and allow it to be able to have the right context for how to operate inside a company as well. Quite right, Peter.
And flipping that on his head a little bit too, I mean, I'm just putting it in human terms. Who would hire a band of interns, 20, 40, 100, a million interns, and just let them loose on their company without any training. That's what you're doing here,
Yes.
right? So you have to train these agents. You have to give them a code of conduct. You have to give them the entitlements and permissions of or permissions, I should say.
You don't just give them a rifle and turn them loose on the battlefield.
No, this is the toddler with a chainsaw situation all over again. Absolutely.
Yeah, and expect good things to happen. Exactly.
So, I mean, I think this is great because, we talked about pattern number 1, which is around the MAS fabric. Okay, we talked about pattern number 2, which is why entitlements are important. And then we've got the idea of, okay, now we can understand the compliance side of it and ensure that the things are compliant by design and compliant in execution. But one of the huge, breakthroughs that I think we had was why we decided to delve into pattern number 4. So Spencer, can you talk a little in your, because this really was your brainchild here. What was the problem? And then suddenly, what was the way that we saw through this that led us to pattern 4?
This has a lot to do with what is currently called vibe coding. So there started to be, models got good enough that you could describe what you wanted, and the model on occasion would actually produce the thing you wanted. So that happened. And as the models got better, that happened more and more of the time. But absolutely nowhere near good enough to put into an enterprise where you've got security regulations, you've got scaling rules, you've got code that needs to be built in a certain way. All of the parts of an enterprise that make enterprise work are almost exactly opposite to the way vibe coding works. So the question is, how could you get an AI to create code that is structured and well formed? So my realization was that we have done this before. How do you take potentially unreliable intelligences, group them together, and then make them produce something of high value? And the example I'd give is a Saturn V rocket. You've got, not sure of the number of people, but I imagine hundreds of thousands, if not millions of people worked on that rocket. And there are millions of bolts and threads and metal plates and all kinds of things that need to be done without mistake multiple times. How do you do that? And it turns out we have formalisms in industry that describe how you tell intelligences that may make mistakes. How do you monitor them? You have line managers, you have heads of department, you have a structure that's built around managing intelligence. And it seemed to be a logical leap to go, well, AI is an unreliable intelligence. Can we use the same ideas to push that towards enterprise quality output? And the short answer is yes, you can.
That's great. So now we're getting into our complete solution. So on pattern number 4 with the Iridius Solution Factory, we've been talking about this from the very earliest days, Spencer, you and I, at the product perspective, and it's becoming real. What's got you excited about this?
The more general view that if a person can do it, we can probably find the rules that the person uses and replicate those in AI, which gives you a really effective way of saying, how can I do this? I don't know. Oh, wait a minute. How did people do it before? Now, it doesn't work for everything, but there are lots of instances where you can say, oh, right, I see how it was before and how it should be. So one of the examples is the way that large single model coding agents work is like an artisanal craftsman. They do it very bespoke. They do it piece by piece. It takes a while. There's a lot of skill involved between the creator and the agent, and you end up with a unique bespoke thing. Fine. That's not what industry needs. Henry Ford spotted that. And he said, what we actually need is lots of small dedicated agents that can do one thing reasonably well and more than a line. And that realization means that we can apply that to agents as well.
I mean, I like to think about it as quantization. And this is what distinguishes what we are doing from the vibe coding, that we are creating a quantized target environment of the multi-agent system that only allows you to do things that are good.
So why does vibe coding not let you do that?
But vibe coding is open-ended. So vibe coding lets you do everything in between.
So vibe coding is great for rapid prototyping versus...
Yes. And the chance that you're going to step on a landmine is much, much higher.
Yeah.
Correct.
At the minute, there's two conflicting forces. One says vibe coding is awesome and it's the best thing ever. And then the other group goes, vibe coding is going to destroy enterprise and industry. It's unsafe. You should never do it. And as is typical, the truth lies somewhere in the middle. Vibe coding is incredibly powerful for, is this even viable? Can it be done?
Yep.
But it's not what you want to push into production. Right? Those are two things. Stop conflating. Don't do that.
Yeah, building vibe coding is not aimed at building you a full enterprise grade, safe, compliant solution. Okay, it's about quickly mocking up ideas, seeing if they would fly, and then saying, okay, now you know what we need to do. We need to build a real backlog with real tickets in it and real items, and we're going to go off and build this thing properly. So you've got a quick prototype. You didn't build a thing. Okay, the Intelligent Solution Factory of patent number 4 says, hey, why don't you take the principles of building something quickly, okay, in a vibe, that Vibe's talking about, but this time, why don't you not just mock it up? Why don't you build the entire enterprise safe, compliant solution in one go? Take that, but that jump or that leap from why don't we just do a mock-up to why don't we have a fully compliant enterprise grade solution is such a huge leap that's, I think, the big thing here.
And this is really the last mile. So tying the 4 patents together, Peter and Spencer, from a customer standpoint, what does the future look like for our customers? And in terms of the future of AI, and what do these patents mean, for our products as a whole and for our customers?
And it's like life, the universe, and everything. It's a big question, right, Philip? I think that one of the forces that the collective patents and our product will impose on industry is a democratization of doing your job. And in the previous wave of this was sort of the co-pilots of the world, where you said, if you have something as a single contributor that you can automate a little bit, the co-pilot can do for you. That is limited by it's in front of a person. The solution is in front of the company. Right, the co-pilot is it requires you to say, okay, are you sure you want to do this? The solution says, I have already gotten the permit to do certain things already, and I'm going to proactively seek out other solutions. So there's a level of scale in terms of organizational scale. There's a level of scale in terms of internet scale, in terms of the consumers on the other end. There's a level of authorization in imbuing the executing environment with pre-authorized rights to do certain things, very well confined, that allows you to just do things faster.
It's awesome.
Yeah, one of the really important things for me was I've always found it really valuable to be able to try something out. And that's kind of what the vibe code gives an individual coder. That is a really powerful tool. Could we give it to enterprise? And I think the answer is yes. We can give them at almost zero cost. At enterprise, it's going to be effectively zero. But in terms of speed, resources, and money, you can try something. And you can iterate on it very rapidly. and maybe produce something really valuable. And that's something you cannot currently do in enterprise. Everything has to be done in a very slow, methodical way. And we think there's a way of doing that automatic.
It challenges the position of SaaS companies a little bit too, right? I mean, the existing SaaS companies are islands of stability. If you say to the industry, actually stability has been pushed into the wall socket, go nuts.
Right. Alistair, any last thoughts?
I think this is giving, companies, enterprise companies, an ability to rapidly iterate and develop solutions that allow them to gain a competitive advantage. I think this is something where they're going to be able to innovate faster and, to some extent, fail faster but succeed faster. They're going to be able to find those things that do not work faster and get rid of them in order to be able to step towards the things that work. And I think that rapid iteration is huge. And I think they're going to be able to do it in a way that's safe and compliant. So they know they're meeting all of the right standards. So they have the confidence that even if they're in a highly regulated industry, okay, where lives are at stake and people are going to be affected, they're still going to be able to build things quickly and test things out with customers in the market, okay, and fail faster, and therefore without as much money and time and resources spent, which means that they're going to be able to innovate in such a freer way that I think, as Peter says, because this is being pushed into the wall socket, you literally just plug a device in. You don't have to worry about how the electricity works. The microphone connects, the power, you can plug a computer in, you take it out again. You don't have to worry whether the electricity is being fed to you in a certain way. If all of that compliance and all of that safety is being handled for you, then really it's up to you to develop and build, and you're only limited by your own creativity at that point. So I think it's a really huge opportunity for enterprises going forward.
I agree. And the one thing it does not stop is a bad idea turning into a good outcome. So you still have to have good intent and good ideas to actually make it work. And I want to caution everybody on that one. My brother Spencer has brought that up and articulated that a couple of days ago, and I go like, he's absolutely spot on. So thank you to the three of you and to the entire team at Iridius for the work that went into these amazing provisional patents and the work that's going into our products to save our customers time, effort, and money, and also create the safe environment that they want for not only their customers and reputational risk, but also for employee safety. When we deal with firms, we are dealing with global firms in pharma and energy and manufacturing, and in each of those scenarios, people die as a result. So public safety is a very key thing that we can help them strive. Thank you to our audience for listening. Join us again next week, and thank you again, Spencer, Peter, and Alistair. Thank you. That's a wrap on this week's episode of the Agentic Insider. Thank you for listening. For show notes and more, please visit agenticinsider.show. To learn more about Iridius, visit iridius.ai. We'll see you next time.